Hey, it's Hutch, and welcome to Module 10. This is all on different types of sampling and statistics. So we're going to walk through this. Really, I just want you to have this good understanding of how to interpret data, how to interpret and compare graphs to each other. And so that's really what our focus is. In order to compare data, you also need to identify if the survey that someone did was actually a valid survey or not. Okay, so that's what we're going to be talking about. You can see a lot of vocabulary that's probably new to you. So we'll go ahead and baby step our way through this. Okay. Let's start off by understanding that I don't expect you to remember all of these words and scenarios. Really, this is about the big picture of trying to just understand if something is a valid survey or not. Okay. All right. So the first bit of things is for us to think about whether a survey is an entire population, okay, which is what we're talking about here, or if it's just a sample of that population, which would be a part of it. And so we're going to go down here and just record down population or sample size. So how many hours of night do you study? If we did 25 students, that's obviously a sample of the population. So let's go ahead and write that down. And if we did all of the students in middle school, that is obviously the entire population of middle schoolers. Okay. What's the town's favorite flavor of ice cream? The residents of the town versus customers at an ice cream shop. Think about which one would be the entire population, which would be just a smaller sample. Okay, so obviously customers are the sample, and the entire town would be the population. And then the last one, who should be the mayor of our city? You ask 350 people, or you ask all the people. Obviously, the all is going to be our population, and 350 will be our sample. Okay, so the breakdown of that is all is population, and anything smaller is going to be your sample size. Okay, so now let's look at different types of sampling methods, and this gets a little tricky, so we'll try to break it down. First thing I want you to notice is this is the only word that's changing. It's simple, stratified, and systematic. Okay, the rest all say random sample. So these are all valid sampling methods, just so you know. Maybe I'll even make it green so we realize that it's a valid measurement system here. Okay, so these are valid sampling methods. Okay, so let's try to break down and understand these three different kinds. Okay, so the simple random sample here, it says each item or person in the population is as likely to be chosen as any other. So it's this basic situation where everyone is equally as likely to be chosen. So an example would be 25 student names are written on slips of paper and placed in a basket. One name is randomly selected. So everyone has that 1 out of 25 chance. Okay, the stratified is when you take a population of people and you divide them into groups, okay, with similar traits that don't overlap, okay, and then you do a simple random sample. So the only difference with this one now is you're putting people into groups first. Okay, and so you might see 6th, 7th, and 8th graders, and then you do the simple random sample. Okay, or you might break people up by ages, and then do a random sample from each one of those ages. Okay, so it's just putting people in some sort of groups first. All right, and then the systematic is your every 10th customer, every 50th customer. It's random based on a specific item or time interval, and you're not choosing any particular group or anything like that. And so it's still a valid sample because you have no input into who the people are that are getting surveyed. Okay, so let's go ahead and try this out. And you're definitely going to want to keep going back to this to refresh your memory. So let's go ahead and take a look. Okay, so example 1. Select valid sampling method that best represents it and circle your selection. So a computer is randomly choosing 500 people from a list of members. Okay, and so think about what's going on there. Are they just simply choosing random people? If they're simply choosing random people, then which one is that? Okay, well, simply choosing random people. Okay, so we have simple random sample. So just focus on simple. All right, they're separated first by state. Which one was in groups? Look back up, putting in groups first. That's our stratified. And then the last one, every 200th, we're counting random numbers, is our systematic. Okay, systematically choosing random people. Okay, all right. You go ahead and try the check now. So pause and think through those situations, and then you can see how you did. Okay, so let's look. Every 8th person. Okay, so that's a very systematic way dealing with a number, okay, of people. So that's our systematic. Okay, let's look at the next one. To test the accuracy of a biometric scanner, a scientist uses a computer to generate a sample of 20 subjects from a population. It's a simple random generator. So this is our simple random sample. And then the last one separates the students by grade, then does the sample. That is our stratified. And even I'm looking back at the words. I don't expect you to remember the words. I just expect you to sort of soak in these different types of valid sampling methods. Okay, so then we get into unbiased and biased. So if you're unbiased, you're not giving, you're not leaning one way or another into how you choose people. That makes things unfair. Okay, so you don't want to be biased. You want to be unbiased. So not biased means that you have a fair way of sampling people. Okay, biased means not. Biased actually means that you are showing unfairness in how you're thinking or acting. Okay, so we have 2 types of bias samples here. So let's go ahead and highlight this. 2 types of bias samples. One is called convenience and one is called voluntary. And you'll sort of understand why they're biased or unfair. Okay, so the convenience one, okay, and I'll highlight this red. The convenience sample, it just includes members of a population that are really, really easily accessible. So for example, you just happen to be eating lunch with this small group of people, so you survey them instead. Okay, so surveying the students that eat lunch with you. Okay, so you only pick this small group. So the big clue with this one is it's a small group. And it's just very exclusive, or what they call convenient. Okay, so a small group that's conveniently there. Okay, especially because it's small, it's not really a good survey situation. The last one is a voluntary sample, and so this happens a lot. It only involves the people who want to participate in it, okay? And so because you're only including this group of people who want to, it's not really fair. You need to include random people, not only people who want to. So this would be like we send out a survey on Schoology and we only look at the data of people who replied in Schoology, okay? So this would be like sending a survey and only seeing who replies. Okay, so that's not going to be fair because it's only including these people who want to participate. Okay, all right, so let's go ahead and take a look and find all the samples that are biased. Okay, so let's go ahead and look through and find those biased ones. So all the middle school students that rode bicycles. So it's pretty good to get all middle school students. There's a problem with this though, right? Can you tell? Yeah, the fact that they rode bicycles. Okay, if we're only doing these bicycle people, that's just this random small group that isn't very random actually. Okay, a social media poll is sent to all middle school students, and a winner is chosen from the participants. So if we're only choosing from who replies, then remember that's a biased sample. All right, every ninth student that walks through the cafeteria door. Okay. We're not just doing this small lunch table. We're doing every ninth student. It's very out of our control. So that is unbiased. Okay. And then D says every person, it doesn't say just every person in the entire bookstore. It says just in this culinary section of the bookstore. So it's this small little group. And because it's this small little group, that makes it biased. Okay, or an unfair sampling method. So let's go ahead and continue to identify types of bias samples for each situation. Okay, and get a feel for how this works. So to get information about favorite animal of middle school students, a survey, student surveys everyone in his 7th grade language arts class. Okay, so think about it. Every single person is getting surveyed. Okay, because the sample is everyone that's available, it is a convenient sample. Okay, and it's a convenient sample because it's just the people in the one language arts class. Okay, so if you're going to do a unbiased situation, then you include all the language arts class, not just the one class that you're part of. Okay. All right. So that's a biased example. Okay. Next one is a news organization posts a survey. Okay. And asks the readers to vote. Obviously, only the readers that want to respond are going to do that. So that is what's called a voluntary response sample. Okay. So those are 2 examples of the bias. Okay. So let's go ahead and see if you can identify the type of bias for these 2. Okay, so you survey a sample of 10 households on your street to determine how often households in a state cut their grass. So think about it. You're just on your street and you're just getting 10 households on your street only. Okay, so what kind of bias sampling is that? It's pretty convenient for you, right? So that's called a convenience. We got to spell it right here. CONVE. Convenient sample. Okay, and that's biased. The managers of retail store mails out a survey. All right, they're mailing out surveys and getting responses. We know that's that voluntary response, and that is a biased sample. Okay, so let's just write that so we have that. Biased sampling. Okay, so those would not work to collect data on. Okay, so let's talk about how to make some valid inferences. So obviously you want to be able to do surveys and actually be able to look at the data and make some decisions based off of them. Okay, so if you have some good valid sampling methods, then you can actually use that data and make inferences. Okay, so that's what we're going to talk about now. Okay, so here we go. On a social networking app, a burrito company asks all of its followers to vote on their favorite style of food. The choices were Italian, Mexican, and Indian, and the results are shown in the table. Okay, so the company said, hey, our most popular style of cuisine is Mexican. Okay, so I want you to think about this. They just put it out on their app and asked people to reply. So going back up, which one is that if you just send out surveys? Oh, right here, sending out surveys. right here, voluntary response, and these are all biased. You can't do that, okay? So let's go back down. Like I said, I don't expect you to remember it. We're doing a little bit at a time here, okay? All right, so let's take a look. Okay, it says identify the type of sampling method, okay? It's the voluntary response, and so that's biased. So determine whether the inference is valid. Because they used a bias method, you can't make a valid inference, and so this data cannot be used. Okay, so let's go ahead and try this one, see if they have a valid sampling method. The customers in a music store one morning are surveyed to determine their favorite activity in their free time. Okay, so let's think about it. It's the customers in a music store one morning. Okay, so think about that sort of like convenience thing. Is that convenient that it's just one music store one morning? To determine their favorite activity, the results are shown in the graph, and the store manager concludes that most Americans either play music or listen to music in their free time. Identify the type of sampling method used. Okay, then determine whether the inference is valid. Okay, so let's go back up, okay, and think about this. Okay, so we have convenience and voluntary. Okay, so convenience is a small group that's conveniently there. Okay, so this is a convenience sampling method, and so it's not valid. Okay, you would have to do a random, like every fourth person who walks in or things like that. Okay, all right, let's go ahead and take a look at number 4. Number 4 says identify valid inferences. Okay, so again, we're taking a look at the sampling method and seeing if we can use it to actually analyze the data. So example 4 says, all right, a shoe store wants to determine if it's customer's favorite shoe color. Every third customer. Okay, remember that's our number 1. Okay, and again, you don't have to remember what it's called. Okay, let's go back and look at our sampling types. Okay, there's the number 1, and it's called systematic. Okay, and systematic is a valid system. Okay, so let's go back down. Okay, and if we look at this one, you can see that's what they said. They said this is systematic random sample. It's not biased, it's valid. Okay, so can we make an inference about this? Yes, we can. So the owner can make an inference to say that the favorite shoe color is what? The red. Okay, that I highlight with blue to make it all funky and weird. There you go, red, which turned purple now. All right, so let's go ahead and do a check. Pause and see if you can figure out what kind of sampling method and if it's valid and what inference you could make here. All right, so 20 customers in a store are randomly selected. Okay, so here's the good thing. We randomly selected 20 customers. So that's, if we look back up, because they're randomly selected, and we look way up here, okay, which one is simply choosing random people? Yep, that's our simple random sample. Okay, so if we go back down, okay, right here we have a simple random sample, okay, and he decided that about half the store's juice stock should be orange juice. So is that valid? Yes, it's valid. Okay. All right. So that's what we're doing. Like I said, it's not the easiest thing. It almost reminds me a lot of like language arts with, choosing the best evidence and things like that. There's a lot to be interpreted. So please don't feel dumb if it seems a little confusing at first. It's okay to go back and think about things. Like I said, this is about you just getting some exposure to what is a good survey sampling method and what is not. Okay, I don't expect you to, for your entire life, remember all those different names. All right, so here we go. This is your homework today, and you're going to identify the different sampling methods, and then you're going to identify if something's biased or unbiased. Okay, and then I want you for number 6 to again, identify if it was biased or unbiased, and determine whether that's a valid system. Okay, so for you to really have practice, you need to completely tackle this on your own. Okay, the only way I'll set you up is to just read through what's going on here. So for number 1, it says for each sampling description, identify the valid sampling method. So we know that they're valid. You're just choosing, is it the simple, is it stratified, or is it systematic? Okay, and so you want to go back to our other notes here and probably have this out for this section, okay, and have this table ready to go so you can be thinking about those categories, okay? And then number 2 is the bias. So this is bad. Bias is bad. So choose from convenient sample or voluntary sample. Remember, convenience is that you just have a small group that's conveniently there, and voluntary is sending a survey and only looking at the people who replied. Okay. All right. And then 3 and 4, I think, are the hardest, where you have to identify if it's biased. Bias is bad. Unbiased is good. Okay. And so looking through there and deciding if it is biased or unbiased. Okay. And then number 5, to evaluate the defect rate of its lenses, a camera lens manufacturer tests every 100th lens off the production line. Okay, so that's a valid situation. Every 100th is getting tested. It's very random. Out of 1,000 lenses tested, 1 lens is found to be defective. The manufacturer concludes that 3 lenses out of 3,000 will be defective. Select all the statements that are true about the sampling method. Okay. So you can go through and think about this situation and see if you can figure out what you would check on there. Okay, again, it's homework, so see what you can do, and we'll talk about it the next day. Okay, and then number 6 here, we have members of a drama club plan to sell popcorn as a fundraiser. To determine what flavor to sell, the members survey every 15th student from an alphabetical listing. Okay, so we're surveying every 15th student. I know that I have like my little number hint here, so that's probably a valid method of surveying. Okay, it says what was the sample obtained using a valid sampling method? Okay, so yes or no. If so, find the percent of students. What percent of students prefer each type of popcorn? Okay, so come up with the percentage that prefers butter, cheese, and caramel separately. Okay, so if I'm going to find butter, I want you to label things. So here's butter, and butter would be 33 out of something, right? I got to add up to get the total, and then I need to get my decimal, and then I need to get my percent. Okay, and then I'm going to go ahead and find the percentage of people who like cheese and do the same thing. Okay, so go ahead and work on the homework, and if you have questions, you can talk to me later.